Next up, we have Brian Field from Comcast. One of the things about having a 900-person meeting is there's actually a Brian Fields also here. Fields, plural.
Where is he?
I don't know where he is. He's close by, but this is Brian Field. It's one field, singular field, from Comcast. He's going to talk about something I think equally cool. This is basically compiling your own routing daemon on a major routing platform. So there you go.
Great, thank you. Yeah, so my name's Brian Field. I'm with Comcast, and let's see, how do we get this thing to work? There we go. And I'm going to talk to you some stuff that we're doing at Comcast. I'm thinking I was happy to see the gentleman before me show some Wireshark traces, because I'm going to show you some stuff as well. What we're talking about today is not just PowerPoint stuff; it's stuff that we're actually building. And the title of the talk is the hybrid open router architecture. And the general idea is that we're looking at, we've got all this hype going around with SDN, and SDN means different things to different people, right? For some people, it means automated configuration on the router. For other people, it means programming TCAM state into the router. For other people, it means, virtualization and service chaining and whatnot. And those are all really, really good and important things. And I think you can kind of think about SDN as kind of like you've got this routing infrastructure, and then you've got this layer of controllers that sits on top of it. And it seems as if much of the SDN innovation stuff is happening at the controller layer or above it. And that's good, that's necessary, that's needed. But I think it's only half of the problem. And it may not be the important half of where we need to do SDN. And so in the talk today, I'm going to talk about SDN kind of happening below the controller level, right? How we can do innovation happening within the router platform itself. So do some of the existing, so the thinking here is that suppose you need a new feature on a router. You need that new feature today. How do you do that? What's the normal process we go through? Well, we go to our friends in the Bay. We plead to them to say, can you please add this feature to your platform? And it gets put into the roadmap, and 6 months later, 12 months later, something pops out. And then you have to go to your other vendors and kind of get all this stuff to work. What if you really, really need a router feature today, right, for your business, whatever it is? How do you do that? Do the existing SDN paradigms help here? And I don't think they do. And I'm going to pick on OpenFlow. And I kind of think of OpenFlow as kind of being kind of like a marionette sort of puppet, right? So I've got my fingers and I've got the strings down to the puppet, which is the OpenFlow API and whatnot. And if I want to make that puppet kick, the only way I can do that is if I have a string attached to its knee and its foot, right? And if I don't have those primitives, I can't make it do what I want it to do. And I think that's kind of where we are with the SDN today. If I need a new feature on a router, chances are the SDN mechanisms don't support what I need them to do, right? So I need to look at another way to do that. And so I'm going to propose a new form of SDN, which is called something I can do now. Let's see. That's not what I was expecting. This is the wrong talk. I guess I didn't get the one that I sent on Friday. All right. This is the wrong talk. All right. Let's go back. We'll go through it anyway. All right, so this, okay. I'll just go wing it with it here. Okay. So in New Orleans, last year, I got up here and proposed something called about applying web principles to the network. And what I was basically suggesting is the web guys have been really innovative and whatnot. And a big part of the reason they've been innovative is because their entire web stack is open. HTTP running on top of, Apache running on top of Linux, running on top of common off-the-shelf hardware. And I was making a pitch, we need to do the same thing in the routing space, okay? And, so I was proposing a year ago, we need to get to this open source sort of paradigm for routing. And we have this huge gap of what we have today, legacy router-wise, and where we want to get to, right? So we've got, these lockdown sort of, boxes, and what we want to do is somehow basically, enable us to basically put our own software on those boxes. And we have this gap between what we have today and where we want to get to. And this is really difficult having the wrong slides, I'll tell you that. So we have this gap between kind of the legacy paradigm of what we have today and where we want to get to. And so the thinking is that, how do we bridge this gap from this legacy paradigm where everything is locked down and an open platform where we have the ability to add our own things into it? And so the thinking is, wouldn't it be really, really great if there was this router platform that consisted of both of like vendor code, but also had the ability for us to drop in open source code or our own developed code? Wouldn't that be a useful paradigm to have? Okay, so the thinking is that can I bridge from this legacy domain to this open source domain without going completely gung-ho to the open source domain? Basically leveraging this legacy platform to do, to add incrementally the things that I need to do to it. And I don't know what slides here. I'm gonna have to flip through this a little bit. Okay, so this is SDN. Okay, and so the thinking is that wouldn't it be really, really great if there was an existing platform that basically ran vendor code on it, but also provided the ability for us to drop our own code onto it. And I don't mean going through an SDK, I mean basically writing your own code that basically talks to the underlying OS directly, okay? Wouldn't that be really great? If that was possible, if this is the unicorns and rainbows, if that was possible, then I can basically leverage the existing vendor platform to do kind of their existing stuff, and when I need a new feature, I can add it myself, right? And so that was kind of the thinking here. And so it turns out, hopefully this is a slide I expect, thank you. It turns out there is at least one vendor platform out there that allows us to do this. That allows you basically you can basically run their code and you can supplement their code with your own code. Right, so you're no longer locked down to kind of whatever the sets of features are on that existing platform. You can add your own sorts of features, okay? It's Linux-based, so basically if you can get something to run on like Ubuntu or something like that, it will run on their box. Allows you to drop in your own code and binaries and whatnot. And so this platform, we're kind of like, ooh, this is pretty cool. So we're thinking, from a Comcast perspective, what would be an interesting use case here? What would be a new feature we would like to add to this platform that isn't available today, or it isn't available on any platforms as far as I'm aware of? And that is segment routing. So segment routing is relatively new technology, introduced into the IETF in 2013. It's not supported on any platforms that I'm aware of today. And from a segment routing perspective, really, really high level, what it allows you to do is to basically do traffic engineering and service chaining. So it's a V6 extension header that allows you to kind of describe how the packet should go through the network, and it also indicates kind of what applications it should, or application endpoints that it can hit and effectively do service chaining. And again, Comcast is interested in segment routing, and we're specifically interested in V6 segment routing. So from our perspective, we have this platform where we can drop our own code in, and we want to try to do our own version, or we want to basically see if we can make the box do segment routing. Okay, just a little bit more details on what segment routing is. The very high level there, you've got a V6 packet. In V6, we have these concepts of extension headers. Inside of this segment routing extension header, you have these things called SIDs. They're /128s, and they basically identify the set of endpoints this packet should actually traverse through the network. There's a bunch of other stuff associated with the segment routing header, but the key here is that those sequence of SIDs basically identify how the packet should flow through the network. Real high level, how does this operate? Basically what happens is when a segment routing packet shows up on the wire, the packet is routed via the normal destination address of the V6 packet. When it gets to the endpoint of that destination address, the process there basically processes the data, and then when it's done processing the data, it basically looks into the segment router header and says, what's the next endpoint this packet should go to? So basically identifies that /128, updates the segment routing header, and then it basically takes that next /128 and it makes it the destination address of the V6 packet. And then it forwards the packet. So you can kind of understand how it allows you to kind of do traffic steering through the network. And again, that /128, that's the destination address, can be an application. Now, again, the segment routing is not something completely new. It was introduced in IETF last year, and I believe in the June NANOG as well, it was presented as well. So this is not completely, new technology. So now I'm going to talk a little bit about what we did here. Again, we wanted to do segment routing, and we have a box where you can basically drop on your own code. And so the first thing you kind of need to understand is kind of, classic router control plane operation. And so, I'll use BGP and OSPF as an instance, but basically, those are just processes in user space that basically bind to an IP address and to a protocol. And traffic coming into that box for that particular IP address or protocol goes through the ASICs. It goes through a hardware filter called COP or something like that, where you basically limit what actually gets punted up to the OS level, and then the application actually receives those packets and processes those, right? This is how BGP works. This is how OSPF works. We need to get segment routing to do the same thing, okay? And so this is what we did. We basically defined a new process, built a new process based on Go, and what it did was it just bound to the loopback address on the box. And then it also bound to protocol 43. So if you look at that IPv6 packet that's carrying the extension header, the next protocol layer is 43. So we basically wrote some classic code that basically binds to the socket, binds to the IP address, binds to that protocol 43, and then basically we started generating packets or have packets that, where the process is bound to that IP address and protocol waiting for packets to arrive. Now, the thing is that, or in addition to that, it's a loopback address, so we force that /128 to be in ISIS into our IGP, so there's connectivity for it. And then we have to update COP. We have to update that control plane filter because now we want to start receiving traffic, not just for the loopback address, but for that specific protocol. By default, it won't get through, so we have to tickle the COP configuration to allow this new type of traffic to get punted off of the ASICs up to the OS level. And then basically the code logic of this code that we wrote is relatively simple. Again, it's binding to a /128 to an IP address, protocol 43, and then you just sit there. Just like an Apache's HTTP daemon would sit listening for incoming connections, the same sort of thing. It's waiting for incoming packets associated with that IP address and that protocol. And when a packet comes in, we know that it's an SR, a segment reading packet, because it's already got, it's coming in on protocol 43. And we basically process the header, which basically means looking at, the index into the segment routing header, what's the next /128 the packet should be addressed to, rewriting the destination address, and then forwarding it, okay? So we wrote this code, we wrote it in Go, we compiled it, built static image, dropped it onto the box, we tweaked COP, and it worked. So what we just did was we took an existing router platform and added a feature to it without the vendor being involved at all. And we did that because it's an open OS architecture. It's just vanilla Linux underneath, and they provide you access to that. Okay, and I mentioned, some Wireshark stuff. I'm glad to see that's in this presentation here. So this is the SR packets that are on the wire. We wrote, not only code to basically process SR packets, but we also wrote code to kind of, to do the decodes and Wireshark and whatnot. So it's a bit of an eye chart, but you can actually see, a blowout of, the details of a segment router header. You can see the highlighted, section in blue below, which is kind of the actual payload, extension header payload that's carrying all the segment routing stuff, and the individual /128s in there. So we actually got this up and running. Let's see what my next slide is going to be. Okay, I'm going to take a step back. So it's not going to be on the PowerPoint, it's going to be me. So we built the ability to basically add a new feature to a router without getting the router vendor guys involved. That's very empowering, right? What we want to do is we wanted to take the next step. When I spin up a process on a router that's segment routing aware, what I would like to do is not just announce that /128, but I would also like to announce that this router has the capability to do segment routing. So the thinking was, okay, when that process spins up, it binds to the port, does all that magic stuff. What I would also like it to do is to tickle ISIS. If you look at ISIS, it's got this ability to do administrative tags, right, which is sort of like BGP communities. And what I wanted to do on this vendor's platform is when that segment routing process came up, tickle ISIS to basically announce, not just announce this /128, but to announce this 128 with a specific tag value. The idea being, you can basically get your IGP state northbound through BGP link state to a controller. Applications see the controller, should be able to see the set of routers that are segment routing aware. So that was kind of the thinking, right? That's what we wanted to do. It turns out that this vendor's instance of ISIS did not support administrative tags. So we're thinking, geez, this would have been really, really cool if we could get this to work. What are we going to do? And so it was suggested, well, why don't you take Quagga? Quagga is open source ISIS. Why don't you just take Quagga, hack in a new TLV into Quagga, and run Quagga instead of the vendor's ISIS? And so that's what we did. We basically took Quagga and again, that's not on here, but we took Quagga, we basically added a new TLV to Quagga, which basically associates a tag value to a /128, and then we allow that tag value to get propagated around at ISIS, and we basically turned off the vendor's instance of ISIS and ran our own instance of ISIS. Okay? So think about that paradigm I was talking about. On the left-hand side, you have this legacy router stack that's completely locked down. On the right-hand side, I was thinking we have this open source router stack, right, where everything is open. And I was, how do I bridge the gap, right, from this completely locked down paradigm to this open paradigm? And this platform allows me to incrementally add features to their box. Okay? So when you think about what we did, the first thing we did was we added a new feature to their platform. We added the segment routing capability to their platform. The second thing we did was we realized that their version of ISIS didn't do what we needed it to do, so we turned it off. We ran our own instead, right? Very empowering, very empowering. Okay, so what does this all sort of mean? Well, maybe this is an alternative paradigm to SDN. And again, when you think about it, again, you know, from my perspective, SDN tends to be, you know, what's happening at the controller level and northbound, all the applications sitting above it. You know, we have, you know, the controller level and OpenStack and OpenFlow kind of tickling southbound, but there's not a lot of ability to make changes down there in most platforms. And I think that's going to be key for us, the ability to innovate on the router itself by adding our own sorts of features and whatnot. That's not supported today or not really enabled by the current SDN paradigm as far as I can tell. When you think about what we're doing here is we have a vendor platform where we've got existing vendor code, and then we can add the open source stuff. Thank you. And so, you know, I don't necessarily need to go completely gung-ho to the open source space, right? I can basically leverage the vendor to do the heavy lifting on the protocols that are off the shelf and I know and love and I know that they work fine. And I only can, or I can add in just the things that I need to add in that are important to me. Again, if I need segment routing capability, I can add that in. And part of the value here is that when you go to a vendor and say, geez, I'd really like this capability, if you have a working piece of code that kind of demonstrates it, it's not just, you know, a PowerPoint, right? This is the value that I think in it. If you actually have it up and running, it's more powerful, right, to convince the vendors that they need to actually do this. So, you know, when you think about, you know, this hybrid sort of model, it's a combination of both vendor code and open source code, right? And you can kind of pick and choose which pieces that you actually want or need at any point in time. And then the thinking is that, you know, all this new code that we're adding, maybe we do open source. Maybe we all collectively, as a community, when we need new features, you know, think about building them together and going down the open source sort of path. Okay. Rough consensus and working code. Tagline from IETF, right? You know, the paradigm that we're pitching here, the ability for each of us to put our own features on our boxes is very empowering. And so think about how that might change the IETF, or what happens in the IETF. For the most part, we're all, you know, unaffiliated individuals when we talk about it at the IETF, but if you can actually run code, if you can actually basically build your own code and run them on the box, that's very empowering, right? So, you know, if you're not part of a router vendor, but you can still write your own code and put it on the box, it empowers you in the IETF space, I believe. And so maybe we need to rethink, or maybe this changes how things happen in the IETF space. Maybe this is going to be good. Okay, let's see. All right, so this is my final slide here, and it's going to be just a quote. With great power comes great responsibility. Right, so think about what we're doing here. Right, we're kind of doing brain surgery on our routers. Right, individuals are going to be writing their own code, or the ability to write their own code and run them on the box. Right, so we're all adults here. We realize, you know, with those risks come great rewards, but you can also screw things up as well. So I realize, you know, we're basically, you know, there's some risk to what we're proposing here, but again, you know, we're all adults and we can kind of figure out what risks are worth taking. Okay, and so that's it. Thank you very much.
Okay, so microphones are open for questions. If anyone has a question, come up. Let me just apologize to Brian for not having the right slides up. We never received them, so I think there may have been an email bounce that happened, and we're going to make sure that we fix that, because we did have one other case where somebody bounced, somebody's slides bounced. But Brian, I'll give you my personal email, and you can send the slides there, and I'll make sure that they get up on the website so that your final slides are actually the ones that are posted.
Perfect, thank you.
Hi, Nick Karchukis from Amazon. 2 questions. Are you going to tell us what you were playing with?
What do you mean?
The hardware platform you were experimenting upon.
Begins with A and ends in Rista.
Very good. Thank you. And
Actually, let me add to that. So they've been incredibly supportive, right? And what I want to make it clear is the platform is the right platform. And in the sense the architecture, I think, is the right platform. I'm not a big vendor-specific person, but I think that's the right platform I think we need for this SDN evolution. So go ahead.
And kind of on those lines, do you see much in the way of, say, just kind of generic hardware vendors throwing out reference designs from like Marvell or Broadcom that we could then extend upon with just open source software to kind of accomplish the same thing without having to build on top of somebody's existing architecture?
So, and I think that's more of the classic open source model. So it's a big chunk that you have to take on at one time. What I'm kind of suggesting here is this is the nibble model, where I can just kind of nibble away a little bit, just add the things that I really need to add to, right? So.
Thanks.
Yeah.
Ignas McDonald's routing system. So it's a comment and question about the changing of Ignas McDonald's routing system. So it's a question comment about the changing of a control plane components. So in a sense, as you presented, ripping them off and replacing with something on your own. So how would that possibly affect the total stability of the control plane and the whole routing system if we don't have the mechanism of capabilities and at least telling the other side of the control plane that something is not as it was before? So there might be vendor proprietary extensions, there might be certain implementations which are different. So if we are talking about a multi-vendor environment, I would probably be concerned about the stability aspects of all of this. Not negating that it's a good idea and it has certain use cases, but what about the stability aspect of all of this?
And that's fair, and that's part of with great power comes great responsibility. The folks that are writing the software now for us, are really smart folks and whatnot. I believe as a community we can build something just as robust as they have.
Okay, thank you.
Yeah.
Jay Fuentes, One Networks. 2 questions quickly. What was the reaction of the vendors once before you moved to Quagga? And the second one, any concerns with security, open source and stuff like that from
So
Comcast?
first one was they effectively proposed it or suggested it. In the fact that since their ISIS didn't support what I was looking for, they're like, okay, we can go look at see what's going to be involved in doing the dev work for you, come back in 6 months or whatever, or their second option was, or you could do Quagga, right? And then what was your second question? I can't remember.
Any concerns about security, open source?
Again, the folks that write code for us today are really, really smart, but I believe all of us here are really, really smart collectively as well, right? So I think there's no magic wand that they have that makes their stuff more secure than what I think we can build together. So, yeah.
Scott White, Google. So how do you handle packaging? So if you have your own software you're developing and you're doing continuous integration, common practice today, and you got a vendor who has some painful 13-week release cycle or whatever, how are you handling the packaging? Has that come up? Have you given that any thought?
I haven't given it any thought.
So what do you think you would do about it?
I'm sorry, what?
I mean, well, you're going to have to deal with it at some point. Do you?
No, that's fair, that's fair. And again, this is more of like proof of concept, like, we can get out of the paradigm of having to wait 6 months, 12 months for a feature. We have a platform in which we can do this. So, what we need to do is now start embracing all the classic software sort of mechanisms to, leverage agile model and whatnot, so.
So, like, did Arista commit to keeping API stable or anything, or?
That's the beauty of it. The API is underlying Linux. Done. No SDK, nothing. Just vanilla OS, vanilla Linux.
Okay.
So, yeah.
Doug Montgomery. So beyond the multi-vendor sort of system effects, do you see any need for the ability to control feature interaction on a single platform? Let's say this takes off wildly and many different groups are adding features to a single running router. Do you think that's a problem, that there's a need to be formal support from the platform vendors?
So I mean, I think I can imagine it could be a problem, right? You know, and that's one of these things where I'll worry about that when we get to that part. I mean, I think, you know, that would be a good problem for us to have, right? If it becomes wildly successful and we have to somehow deal with the fact that there's many people that want to do the same sort of thing. It wasn't in my slides, but it's been something that I've been thinking about. And I think kind of, you know, the classic how we do things like IGPs, I think are broken, right? And maybe this is going to be heresy for in here. But, you know, I think we need to kind of rethink our models around IGPs and whatnot so we can decouple the different groups that are adding different features. So if you think about like ISIS, everything's jammed into the same process, right? Wouldn't it be really, really cool if I could have a V4 ISIS listening on one port, another V6 ISIS listening on another port, and another ISIS process doing service discovery, and they were independent of each other, right? I think we need to kind of rethink how we do our networks to kind of allow agility, allow these people to do evolutionary sorts of things and not worry about, oh crap, we just blew up the V4 topology because we were adding a new feature for service discovery. Yeah.
Darren Lohr from Microsoft. This is great work. I really like this. What do you think about contributing back into the Quagga project?
Actually, that was a slide I had. And you know, when I first started doing this, you know, internally, you know, started digging around, okay, what's the process for doing open source in this stuff? And then I got this, you know, 42-page document I needed to fill out. And so, and rather than fill out the document, I can continue to do working. But that's something I will own and try to contribute it back. Yeah.
Microphones are closed, by the way, so last two questions.
Girish Chandran, Wiresat. So did the vendor allow you to tie your code into the high availability architecture? So, you know, there are some set of platform services that come with building these features. So do they allow you to do that?
So I didn't address any of that at this point. So,
Okay.
okay. And then back there.
Hey, Kevin with eBay. I'm curious, sort of, I think it was Scott with Google's question. How did you actually get your Quagga to program the routing tables of the hardware without an API?
Yeah, so it just leverages existing OS routes and then pushes those down.
Okay, so it basically it syncs it to the OS routing table, which already syncs to the hardware. Is that the way it works? All right, thank you.
Okay, good, great, thank you.
Okay, thanks, Brian. And again, you did a great job of winging it there too. I don't think anyone would have known if those weren't your real slides.